This is KOJRO with a new video for you. As you can see, there is some stuff going on behind me on the bench, and actually it's my IBM AT, the very rusty one that I actually started working on this summer. The main board is behind me here on the bench, and last time I powered this board it was completely dead, so it could be anything, and I do have some use for this board, and I was thinking about doing some modification to it. This board has no BIOS built-in setup for the BIOS settings, so I understand that by changing this BIOS to an Avard, Phoenix or AMI BIOS, I will be able to have a simple setup screen to go in and make changes. And I do have some other boards and stuff that I want to test, so I also want an XT IDE to fit into this, maybe an Adlib card and some other stuff, so this will be more usable than it is today. So my plan today is just to get this board to post and get it working, and I will follow up on this in more. This is not by any means a part in a series. This is an episode that stands on its own legs. I'm just going to repair this 5170 80 motherboard, and this is a late revision. I think they count 3 revisions, even though it's really only 2 revisions. It's the first revision that has a larger board, and the second and third revision is the same. It's just that the speed on the CPU is 6 MHz on revision 2 and 8 on revision 3. And otherwise the board is about the same. There are some timing issues, I understand, that the room ships needs to be faster than 190 or something nanoseconds on the 8 MHz, and 250 is okay with the 6 MHz. I'm not completely sure of all the differences. I have not digged into it, but we are going to do that now. So first, I'm just going to put this up on the bench. I already did that, as you can see, but I will go into depth and tell you what I do. Let's follow through with the process. So let's move to the bench. This dusty old thing here is the motherboard of one of my 5170 IBM ATs, and we tested this back in, I think it was in August this year, and it did appear completely dead. And I've taken it out of the box again, and I'm trying to get some life into this again. And to do that, I'm going to use an ATX power supply. And as a general warning, when every one of you tries to use these modern power supplies on old hardware, this board is rated to take between 7 and 19 point something amps on the 5 volt, and of course 20 is when this is fully populated, and that's not going to occur while we test this. But this is an 850 watt power supply, and it's only supplying 20 amps on the 5 volt rail. So the 5 volt rail is under supplied on these voltages, is almost not in use at all. But the 12 volt, that is only going to draw about 8 or something with a fully loaded IBM IT. It's going to supply 70 amps on this. So the 5 volt rail is the dangerous thing on these power supply when you are using them. And I'm just going to use an e-bibe, this converter thingy. I'm just put the switch on this. I've used this one before, and we are just going to use this when we start measuring up on this board. It actually was a bit cumbersome to get this on, like so. And as always, the ground connection should be pointed to the middle, like so. So with that out of the way, I do have to make some other decisions here. I'm just going to turn it on. I do have the VGA card that originally was in this computer. You can see it's a bit rusty here on the connector still. I have cleaned this connector with some dioxide. Otherwise the card looks to be in a really good condition. There are some slight discolorations here on the bus fingers, but nothing much. This is a Trident 9000 card. I do think it's a 256K card. I'm not sure. Well, maybe it's 512. Because you do have, it's a 512 card, because this is 256. So it's quite a good card to make this, if we can make this work. And you do have this switch here that is supposed to be switched if you do have a color or monochrome system. And I'm going to try this first without a battery or anything. And this motherboard is totally original. It has never been worked on before, I think. So what I normally do when I have a system like this is that I will start with the diagnostic card. But I don't remember if the IBM IT, I don't think it have in fact some error codes on a standard memory location, but I can check that. But I do know that there are other BIOSes that will fit into this that do have diagnostic codes, and there also are some diagnostic rooms for the IBM AT. So we might try that as well. So I'm also going to bring forth my EEPROM programmer and see if I can download some diagnostic rooms for this. And otherwise we just get cracking and see what's happening. To be prepared, I'm just going to erase some EEPROMs, and this is all 27, 256, 32K EEPROMs. And I normally supply this with 12 volt from my lab power supply. Of course I have other 12 volt power supplies here, but I normally use this as it has the 4mm banana leads already connected. But this time I made a mistake. The current limiting was on, so it didn't start right away. I have now set up my AT board on the bench. I have connected the VGA card. I have a VGA cable to flat screen 17-inch monitor that I have here. I have my power supply. I have the other hookup, and I also connected a power LED. And the last time we tested this board there was absolutely no life in it. And it takes some time before anything happening on the screen anyway, but I'm going to wait a bit. And nothing. So we are going to connect our diagnostic card. I take this old one. This is, I have ripped off the speaker. There was this piezo speaker on this, but I don't remember what happened, but I do think I broke it off by an accident. Just going to connect this. I do have one more at least of these diagnostic cards, but this one has this connector to fit an external display, so we will be able to see what's going on from the top. I don't know if this will be visible on camera if I don't turn off the overhead lights. Let's see. Now I just have on a small light. Turn on the switch. Yeah, it's DD0100. DD0100DD. Okay, and that tells us something. I have to go and check, but I do believe that that is a memory bank 1 error. So I have to check the manual and see what's going on there. Yeah, in doing this repair, I'm going to lean heavily on -0degrees.net. They have an excellent page with a lot of resources for the old IBMs. I really urge you to check that out. As we saw on the bench, this motherboard was actually stopping with a DD code. And when it's a D and it loops into a D and 2 other numbers, it actually means a memory fault in RAM bank 0, as it is for this board. There is only RAM bank 0 that is fitted on this board. Otherwise you have to have an extension card. And as you remember, we did have a DD followed by a 0, followed by a 1. And that means bit 0, ship in bank 0. And bank 0 is, of course, everything is bank 0 on the revision 3 motherboard. And they say it's the bit 0 ship. And IBM have really been kind to us, because as you can see here, they have marked the ships with the bit, corresponding bit on the motherboard. So this is probably the culprit right there, but we have to check, because it can be other things that is also making a memory fault like this. It can be some control logic, it can be the CPU, it can be, or it's, I don't think it's the CPU, but it can be. And it can also be the buffer logic. There are some 244s or 245 buffers and other things that controls this. So at least the diagnostic tells us this. And it actually is so that if you have multiple faults, it actually will tell you which other bits also is at fault. And they have a quite ingenious scheme to figure this out. So you can see here they make this, in our case we had just a 0, it was just this one, so it didn't matter much. But as you can see here, they actually put the bits together so that you can see they are marking each bit in each byte here to actually decode what is wrong. So the 104C, this is just an example that is from the 0 degrees webpage, and there they have this bit, this bit, this bit and this bit marked as wrong when they do the memory test on the startup. This memory test, as I saw, it's not foolproof. And the memory models that are on this board is, as we saw here, it's the 41256. But there are lots and lots of vendors of these chips, and what's in our computer is a NEC chip, or it's 18 of these NEC chips. I do have another board that is fitted with Gold Star. I have not checked if they are swapped or changed or anything, but every vendor had one or another compatible chip, and that is a 1-bit 256K configuration back in the day. And they have different naming for this. The NEC had the 41256, that is the one that I know this. I've always called this a 41256 because of this designation. But you can see here that Intel, they have their 51s, and Gold Star have their 71s, and you have other means here, the 53 from Hyundai, the 1256 or 4C 1256 from Austin or Micron. You have a lot of different naming conventions on these. The important part is that they have the 256 by 1, and also that it can't have any faster refresh time than 4 milliseconds. Today, update frequencies is counted in microseconds, but 4 milliseconds. And you do actually have some strange beast here. The 256K by 1 from Hitachi, they have a version that actually can handle a 32 millisecond refresh time. And just to make an explanation of what this means, a 4 millisecond refresh time means that the memory has to be refreshed. Static memory does not require refresh, but dynamic memory is just a capacitor and a transistor gate, and this capacitor has to be recharged every 4th millisecond, otherwise it will lose its charge and go into an error situation. But this chip down here, it actually only needs the refresh time each 32 milliseconds, and that means that you can not delay executing and other stuff on the computer each 4 milliseconds, but instead you can do it each 32 milliseconds. So even though it seems like the 32 millisecond is a slower thing, it actually is a very good thing, because instead of you having to do the refresh every 4 milliseconds, you can do it every 32 millisecond. I don't know if these options are in this computer. I do know that the 8 MHz variant do have some wait states on memory, because I do seem to remember that the 5162 that runs on 6 MHz is about as fast as this, because it doesn't require wait states on the memory. But the memory is stated here that it needs to be at least 150 nanosecond access time, and that is what is supplied on the chips that we have on our board. It can be faster, and other values of this is 120, you have 100, and you also have some with 80 nanoseconds. So this is just an overview of what this memory does. Now we are going back to the bench again, and we will test out these chips. Yeah, so that's confirmed then. It's a memory error, and it actually states that this is bit 0. But all the memory in this board is socketed. It can of course be a bad contact in one of these sockets, but I think the easiest thing to do is just take the Retro Chip Tester Pro and test each chip and see how it goes. It's actually not the easiest thing, but it at least will confirm if the memory chips are good or not. It can of course be memory controller, it can be some of the latches, it can be some other things, and it can just be of course oxidation on something. But let's just test the memory chips. I don't have my chip pulling tool here, so I'm going just to wing it with a screwdriver. And I'm just going to place them here in the same fashion that I pull them out. And I have my anti-static wrap around my chest as usual. And this blue mat is also properly grounded, of course, because when it comes to all memory chips, even though they're dynamic RAM and not static, static electricity can be a beast. These are ceramic capacitors, even though they have the same color as the tantalums. I have not had exploding tantalums in this one, and they all measure just fine, but I don't think this board has been seen much use. So the case, as you might remember, was a bit rusty and had some wear and tear on it, but it was really clean inside, and of course people has been in this. They have at least changed the VGA card at some point. There is no visible corrosion on this, but it can of course be just because you have two different kinds of materials that's been sitting against each other, then it always will be some corrosion if you don't have a material that is not reacting with another, like stainless steel or gold that doesn't react with aluminium or what else is on this. But these are not silver plated as some of the chips was back in the day. So that's every memory chip out of the way, and we grab the Retro Chip Tester. And last time we just connected this with USB, so that's probably good enough. And we can actually test the first bit. Bit 0 is actually this one. These memory chips are 41256. FIFO DRAM uncommon, DRAM common. This must be one of the most common ones. (44) 41256. And okay. And these tests of course take some time. I can of course dim the lights even further. Well, this actually failed. I will try to rub the legs a bit, like so, and test again. It would be very simple and very boring if this actually turned out to be the fault. We tested fail on the same place again. So I'm just going to put this aside, and I'm just going to test all the others systematically. I will just take this and mark it with 0 and then X so I can find it. I see here it's a checking 1. I do wonder if this is running endlessly. It's testing different bit patterns. Maybe that was it was noting it was checking with 1, and now it's 0 1 0 1 and so on, and 1 0 1 0. So it's running this test for a lot of different bit patterns. Hopefully it doesn't do a random afterwards. Yes, random, of course, one more time. This is a real true out test. I could of course test them with my other testers simultaneously and check how this goes. Oh, it was satisfied with that, but then I won't bore you with testing all the other RAM chips. I will just skip through this until I eventually find another fault. Yes, and this was the last of the ships that was originally, and I have a ship here. It's a Oki ship, but it should be the same specifications. And let's just test that too before we put it into the circuit. By the way, this ship, I don't remember where it come from, but I do think that this actually is new old stock memory chip from back in 1992, I think. Yes, and that was okay too. So then I have a fully working set of, or at least the Retro Chip Tester Pro has told me that I have a working set. So I'm going to put this into the board now and see if that was all it took. Yeah, we have now tested all the memory chips, and I'm just going to use some deoxide cleaning into these sockets. Yes, that was the deoxide. I'm just now going to put the chips back in their sockets and replace them where they belonged originally. So the OK chip is going into the bit 1 socket. Yeah, that was all the chips, and we still have the diagnostic card connected, so we just put the power on and see what happens. Yeah, and we have some diagnostic lights, and it's not stuck in the same loop as before, so it's going further through the post. And we have something on the screen, so it seems to be working. We have keyboard error, we have floppy drive error, CMOS settings error, all as expected. So, probably we have a working system now. At least we can try it with something bootable and see if it boots. But that will be the next episode, I think. Yeah, don't you just hate it? You have looked forward to do a repair and just one small fault and it actually works. But it's a good example of a typical fault finding process because the fault is really simple. The multiple fault scenario is things that is stored bad. Of course, this one was rusty, so it's not been stored optimal. But one memory chip, it's at least what's counting as bad for now. I will connect this up to a keyboard, maybe a floppy drive, and I will also try to swap the BIOS for something else. And when I've done that, I'm also going to put an AdLib card and try this to see how the experience was with an AT from 1984 or 85, as this was most commonly produced. But I think this is a later model. I do think I found out that it was produced in 1987 or something. I can check on the chips, of course, but it is what it is. So, hope you enjoyed the content. The next episode will probably be a bit different. We are going to put this further to the test and attach some other stuff to it. So, hope you enjoyed it. Please like and subscribe, and please look at my back catalog for some of the older videos. I could use the view time. The algorithm with YouTube is kind of unpredictable, and I need more viewers that watch more old videos and spend some more time on my channel. So please like and subscribe and see some other videos. Until next time, take care.